So now we will continue with the geosynthetics application of geosynthetics in the field of coastal engineering. So here this is one of the major project carried out in India. So it is for so there is the application of a geotube. You see the geotube is taken in a barge and then geotube is laid at site. This is mainly to protect the caving in of the side slopes of approach channel. This is somewhere in Aldia port, and this was a very successful project so far. About close to the same location, you have the installation of geomatrices. This is particularly helpful or useful in the case of leveling and also making sure that the soil is being retained from erosion. So again this is the how the geomatris is being laid there in the bottom one, and there on the top you have a lifting of Gabion. So with this we will move on to yet another major project. This is in Digga beach. So this is in West Bengal, and there was an urgent need for protecting the site. So this site, so this is in West Bengal, and this area is called as Sankarpur. Only this location wherein you have a good amount of beach formation. Unfortunately, due to the unprecedented coastal floods during a few years back, the entire stretch of the coast was washed away, and in fact the land was also inundated, and the people had to run away from the coast, leaving all their dwelling units. So this was taken up on a war footing, and initially there were proposals for protecting it with rubble. There are 2 points. Rubble stones were not available in the near vicinity, and it has to have it has to be brought from a long distance. The second point is that the local people did not want to have any stones because they did not want to spoil the beach. So hence there was some kind of alternate kind of solution which need to be thought of, and then when we visited the site, this is the kind of scenario. So you look at the erosion, this is called as locally balas. So this is just rows of timber logs, timber poles driven, and you have horizontal bracing also, and inside that they keep sandbags. So unfortunately this is all the way continuous. So this was not providing them much kind of relief, but maybe it was offering them a kind of temporary relief for a short duration, but then the net effect was that erosion was still continuing, as you can see, in spite of the balas. So you have the erosion taking place. So this is the stretch of so as a pilot project we considered about 800 meters wherein this need to be implemented. So how did we go about? So we naturally went in for the geosynthetic material, and this is a site before the remedial measure, and this picture obviously has been taken during the low tide, wherein you can see the status of the coast clearly. So the initial section, how do we go about it? So we need to look at the different elevations, and the problem is you have to give a solution. One is for protecting the coast, second is you should not have much of inundation into the land. So in which case we need to consider all the levels. So the top level, so we considered 3 geotubes as you can see here. Geotube is, it looks circular, but when you fill it and then lay it, it looks takes the form of an ellipse. So then we had this blue color is the geotextile all the way here, and as I said in earlier lectures, the toe protection is extremely important. So we had a toe protection here. This is nothing but a kind of exposed toe. So you have the geobags here, a number of geobags, and then you also had here we provided geocontainers filled with sand, and then over this we had the geomat for certain locations, and then but the geotextile was running. You see, look at this point, this is where the anchoring was done. On the other side, this was anchored onto the land somewhere here, and at a much higher location. So you see that this area was filled after laying the 3 geotubes. In order to, I did not touch upon the UV resistance. See, one important one of the major problem with geosynthetic products is the UV resistance. If it is exposed to the sunlight over a period of time, the geosynthetic material becomes brittle, and there is a possibility that for it breaks. In the event that it is completely submerged below the water, you do not have this problem, but when it is exposed to the sunlight, and there is no kind of a guarantee for how many years the geosynthetic products can sustain in a kind of weather like what we have here, for example around 40s during summers. So this kind of weather, the sustainability during this time of period, this period is extremely important. So in order to address this problem, you see that an extra strand tarred poly rope tubular gabion that was adopted, and we had a extra coating over the geotube, that is the top geotube, wherein that was nothing but the UV stabilizer. It is a kind of a coating which is given to the geotextile, which is wrapped over the top, at least the ones which are directly exposed to the sunlight. Even today there is not much of problem with the quality of geosynthetic material, although it is around I would say it is around 5 years. So what happened is, this is the kind of scenario, and once these tubes are laid, then you have the filling that was suggested here, that is natural rock, so that you do not really that aesthetic point is preserved, and then probably we can expect some quantity of beach being formed in front of the geotube, as well as this obstruction can serve as a protection measure in prevention of the flooding during extreme event. So what was the site condition? This was the kind of a site condition. So what was done is, initially the construction sequence I am just suggesting, a temporary bund was constructed from excavated earth and sandbags. Then the excavation took place here, excavated, this is in fact for mostly for placing the geotextiles. So and then the placing geobags at 11.3 meters distance from the line of existing sand wall. So this was distance. A trench of this size, 3 by 1 into 100,000 meters for the entire length was dug. The excavated material shall be used for construction of, so this material was used for construction of the bund, and that bund was also provided with sandbags, and then once this was done you have the excavated thing. So you have you run the geotextile, making sure that you follow all the basic requirements, and the geotextile is also taken below the sand, and then the geobags were put in position here. Then you have the geocontainers filled with available sand. These are slightly bigger than the geobags, and now this is how the toe was constructed. Once this was constructed, then the two geotubes are placed over this geotextile, and then after this the third one is also placed, but make sure that the geotextile is running through, and you have the geotube filled up, and geotube with the UV resistance cover. Once this is done, the sand filling between the geotubes was done, and this is finally you had this kind of a cross section that was implemented in Shankarpur. Once this was done, what happened was, this was done initially for about a distance of 100 meters, and surprisingly we saw that the geotubes were intact, but kind of a tilt took place because of yielding of the toe. This is a kind of an exposed toe, kind of a toe, although I use the word excavation, but the depth of excavation is not much. So that means it can be still called as so you see this the order was about only 1 meter, I think, or less than 1 meter, or of the order of 1 meter. Then we found that the damage took place for the initial 100 meters or 200 meters, and then we had to go for another 800 meters. Then we looked at the problem, and then we found out that this is the main culprit, that is the toe. So we needed to strengthen the toe. So what we did is use the same procedure of having the temporary bund, continue with the temporary, the bund was already there. So we increase the depth of the toe, and then also the width, and then we had placed in position a number of geobags as well as the geocontainers. So the excavated toe added to the strength, and there was no disturbance, and the entire thing was intact. So this was a revised section adopted. Then let us see some of the photographs, and this was around mid of 2007 and early 2008. This was done sometime around mid 2007. So you look at the initial geobag, the bottom one, and then over which you see this bag. This geobag is provided with that UV stabilizer, and then once this was laid, you see the filling up of the position, that is this position, this location was filled up with the beach material, so that the people are not starved. They do not starve for beaches, because they have been exposed to this kind of an environment, and I mean with to the beach, and now suddenly they are deprived of the beach, and in order to win back the beach, this was the idea that was suggested and implemented. And you see the view of the geotubes along the Shankarpur coast for a length of about 1 kilometer. The project was quite successful, but there were a bit of shortcomings. The geotubes are in position, but some locations have been damaged. So let us look at the problems. So I would like to say that the title is now performance as well as damages. So you see that these pictures show the stability of the geotubes against the waves, and I would not say that these are 100% extreme waves, because it has withstood waves much higher than what you see on the picture. and stability was not a problem. But there were other shortcomings, and what were the shortcomings? Tearing of the geotube, geomaterial, geosynthetic. It is possible, that is vandalism. There is a possibility that people just put a knife and then dig it out of curiosity to see what's inside. That is one possibility. But you just tear it, I don't think it comes. But then if you use force, naturally there is a possibility that it gets torn. The other possibility is, the other problem was, when they fill in the tube, if they do not fill in to the complete level, then there are depressions, there are unevenness over the surface of the geotube. So then in that case what happens, you have tension created, and there is, in due course, over a period of time, there is it gets torn, and then once it gets torn or punctured, then it is a problem. Other serious problem, so some of these damages, once it is damaged somewhere, you need to have immediate rectification. If you fail to do that, then that leads to catastrophe. That is the biggest disadvantage with geosynthetic products. But see, as I told you in one of the lectures earlier, see this gap, that is placing of the geotube, so it needs a lot of skilled labor, and also kind of dedication is needed. So when you are placing two geotubes like this, look at the gap. So this is what happened. For example, there is a gap here, and when there is a monsoon, the water flows through this, and this is a small gap, and hence the velocity increases there, and then once it increases, then you see that one geotube goes below the other, and then you have an unequal settlement, and the geotube itself might yield. So this is one of the major problem which needs to be done. So in the case of geotextile, I have already said about the overlapping, but in the case of geotube, you have to make sure that it is intact, and that is not so easy to achieve. Now we move on to another case of in coastal protection in Uppada. So herein what has been done is, you have a toe protection based on the experience we gained in Digga. So this is the kind of protection measure. You have the geotextile here running all the way, which is shown here, and over which you have the geotube, and over that we have placed the geobags, and over that have the gabions. This has proved to be very good, and it is quite successful, and we are likely to continue with this project. For this has already been done for about half a kilometer, and additional stretch of the coast is likely to be protected in this fashion. Gabions are, as I told you, is also very nice way of protecting the coast, and you see that here you have the geotextile, the geobags, that geobags act as something like a cushion, and geotextile prevent the soil erosion, and then this gives the resistance of the waves, and over which your gabions can be placed. Advantages of gabions: use of locally available smaller stones of maybe 40 up to about 50 kgs, or even cement concrete blocks, sometimes they are used. So you avoid heavy cranes and then machinery, and then use of locally available manpower. One man can lift one gabion if possible, if he is really quite strong. Faster and easy construction and maintenance, more porosity in the armor layer, ensure effectiveness of dissipation of energy, incident wave energy, and it is also quite environmental friendly, provides growth of vegetation, that is another important thing. In fact, when you have the the gabions also coupled with the geomat, that helps in growth of vegetation, that is very good. Limitations: limited life, more if buried and well maintained. Periodic repairs and maintenance is absolutely essential. That applies not only for gabions, all other geosynthetic products. removal and reinstallation of gabions is quite tedious than just rubble mound, because rubble mound you are going to have bigger stones, but here it is going to be a big problem. And then sandbags or geotubes. Then the other problem, this applies even to geobags or geotubes or sandbags. The other problem is when you have gabions, this boat people, they try to tie their boats to the rope, and this sometimes poses some problems, and sometimes the local people cut also the rope. So that is also dangerous. Once the rope yields, then it is a problem. Earlier there used to be some steel ropes, but galvanized steel ropes, but this was not so successful. So they have now polypropylene ropes which are quite effective. So this is yet another location, that is so the location is shown here. So the idea was to have geotubes as shown here, one 3 meters diameter geotube and 1 meter diameter tube, and this 1 meter geotube is to just act as a toe, and this was a site, and this is the kind of implementation they had for this area. And then this is in Goa, where you see the series of geotubes provided there, and if the same kind of geotube is oriented just below the water level, it can facilitate a breaking also. So this is a kind of another kind of concept that is being thought of or adopted. So concluding remarks, well placed and maintained gabion structures provide reasonable defense against wave impact. They have sometimes some advantages over the conventional methods. The geotubes have been used successfully as temporary coastal protection work as well as artificial reefs. Then life of structure under continuous action needs careful attention at the initial right from the initial stage itself. So that concludes with a variety of problems, because the reason why I have covered a number of case studies in geosynthetics is that there has been a discussion, or at least people are of the opinion that not much of work has been done in our country with geosynthetic products, particularly in reference to the coastal engineering, and this is the reason why I had shown you more number of case studies, and in fact I have limited, and there are much more case studies that have been wherein geosynthetic products have been adopted. Okay, any questions? Shall I proceed? So when you deal with the geosynthetics, one is the strength, the property, the material properties of the material need to be tested, which I have already covered. The other one is the performance of the structure as a unit. Mostly it is on the hydrodynamic stability, on its hydrodynamic stability, which is I will just present a few studies what we have done in IIT Madras. This is the Department of Ocean Engineering, and we have a flume wherein we test we carry out such studies. So here the objective of the study is to test the hydrodynamic performance of geobags as a core layer in a typical rubble mound breakwater, then also to test the hydrodynamic performance of gabions as armor layers and toe for a typical rubble mound seawall. This is a wave flume which we have, and this is 72 meters long, and we have a wave maker here, and the water depth can be varied from about 0.3 to 2 meters, and we have it is a wet back, so you have water on the rear side of the wave maker. In order to take care of the reflection within this area, we have progressive energy absorbers which die down the which absorb or dissipate the energy behind the wave absorber, and we have a parabolic absorber here in order to absorb the instant wave energy, so that you are dealing only with progressive waves in the wave flume. For the reproduction of the ocean waves, heights are modeled with a model scale of lambda, and the period will be alpha, lambda into the square root of lambda, and the weights will be modeled as lambda cubed. This I have already mentioned during in the lecture on stability of breakwaters, and based on whatever units we have the tetrapods. So we had used it as 1:12.6. The material geobags was provided, the sizes are given there, and these were filled with the sand which was used as a replacement for quarry stones. So instead of the core layer, so core layer, as you would recollect, you have the armor, secondary, core. So this is replaced with the geobags, and this is the cross section in the prototype which we had selected or which we had adopted. So in the field it would be having 4 tons tetrapod, a secondary layer 272 400 kg stones, and the core layer would be 100 kg up to about 100 kg stones, and the toe is 272 400 kg, and we also adopted a filter layer, that is quarry run stones 5 kg. So this is the model. After adopting a model scale of this much, the cross section that needs to be tested in the model is shown here. So the tetrapod weight is around 2 kg, and other things are indicated in this picture. And in the case of geotube, the same tetrapod was adopted here, and you had the geobags filled in the occupying the core layer. So these are the testing conditions. So we partitioned the flume into 2 halves. So the width of the flume is 2 meters. When we partition this, you have 1 meter and 1 meter. So you have the wave gauges here in order to find out the reflection from the structure, and also the structure, one with the tetrapods with a rubble stone in the core, as the core has been placed. In the other compartment, the geobags occupying the core has been placed, as you can see here, filling the geobags in the flume and placing, and now you have both the cross sections, and we had subjected this to a particular wave and wave height, that is, this was designed for a particular significant wave height, and the testing would be, so the significant wave height that has been tested in the proto for this was around 2.8 meters. So then you see that it has been subjected to 25% in excess of the significant wave height, and the corresponding prototype wave height wave period is given here, the model etc. model values are also provided here. So then we use a usual procedure, that is unit rocking P category. This I have already explained, so I do not want to repeat, just touch and go. So the percentage of damage is number of units displaced divided by the total number of units. So this was visually done as well as done through online recording, and all this category, unit permanently but only rocking, unit displaced by 0.5 times the diameter means equivalent diameter, and R is unit displaced by 0.5 to 1 meter 1 diameter, and S is more than 1 diameter. So which, when you add all these quantities, all these classes, then you get the damage level. The damage level should not exceed 5%. So now you see that the cross sections are tested for a number of scenarios, and then you see that in all the cases the damage level was well below 5%, and then both the cases with the core replaced by your geobags were also equally good, and So that results in a lot of saving in material also. So this is in the case of Gabion. So what we have done is a seawall, as you see here, all these things are core stones, this is core stones, and this is the filter layer, and this is the armor stone, as you can see here, and the armor stone is 1 ton to 1.5 tons, and instead of having this portion and this portion has been replaced with gabions. So this is the gabion which is shown here, and this is another set of gabions which are glued to, I mean joined together, and this has been this in fact working quite well in the field. So these are the gabions that was fabricated in the flume, and before this we had a geomat also over the sand. So this test consisted of having a geomat, so instead of a geotextile, and then laying of the filter layer, then laying of the armor units, I mean the gabions at the 2 locations indicated in the earlier figure, and then it was subjected to the water depths indicated here, and the wave heights are provided here, and the significant wave height was 1.2 meters. So you see that I think the different wave heights were tested here, and then some of the results shown here, and finally you look at the result that the stability was well below, the damage was well below 5%, indicating that the assumed cross section or the designed cross section is quite safe. This kind of assessment is extremely important, and so to conclude this my lecture on geosynthetics, geotextile containment presents interesting possibilities for hydraulic and marine structures. Geosynthetic containment works as mass gravity units and provide real soft solutions. Solutions can be low technology or high technology depending on equipment available. So the product can be same, but still it can be converted as a low technology, but whether even if you convert it to a low technology, still you need to have skilled labor for this. Important considerations are like availability of sand, skilled labor for laying, machinery, and UV resistance, which I have already highlighted during the course of my lecture. So we have seen the application of geosynthetics in the marine environment, taking an upper hand or gaining a lot of momentum in its application, and so this is treated as eco-friendly, as I have already said, and it is quite easy to handle also, and it is not an eyesore unlike when you use rubble mount structures. So now this demonstration is with the help of geotube, which has been considered as a coastal protection measure somewhere in Merida, that is in Mexico, and I could get this 2 videos put in along the coast of Mexico in one of the important residential areas, in order to take care of the residential area with this provision of geotube, because they didn't want to have stones etc., because they wanted to have the same kind of a scene. I mean they do not want to lose the view of the ocean also. So what you see all this beach houses here. So now how does this I should place on record my sincere thanks to Access Engineering, who are the main consultants for these 2 projects. So this will give us a clear indication, as here they are using they have adopted a geotube, submerged geotube. The idea is once you have a submerged geotube, it will allow the premature breaking, and there will be the dissipation of wave energy, and then it will because of the dissipation of energy you can have an enhancement of beach formation, and also not only just protecting the coast, but also it will enhance the beach formation. So now we will see this but there is a way of designing this now. So let us examine with the phenomena of the submerged barrier or the geotube, how it what kind of information is you need in order to, and how does it perform. See, now herein you see that both are submerged near the beach, and you see the difference. Here you have the dissipation of the energy, and that is going to enhance the beach formation, but the same geotube is fixed here submerged, and you see that this is acting as a reflecting boundary. So if you have a reflecting boundary, what will happen is, instead of protecting the coast, the wave the reflection is going to be high, and then that the amplitude also will be increasing near the structure, that will facilitate your erosion to take place, and once the erosion is taking place, the stability of the geotube also becomes questionable. So hence before identifying, you have to put in a lot of effort in making sure that you identify a proper location for the submergence of this geotubes. So this depends on the prevailing wave climate, the kind of beach profile, and so many other factors which govern the response of the geotube in protecting the beach. So these are some of the references available. All are excellent references given, and I would strongly recommend Pilarisk Geosynthetics and Geosystems. It's quite a good book, and also there are other guidelines which are available, which can be used for this kind of investigations. So I would like to place on record, particularly for this lecture, a number of, I have taken material, as I said, from number of sources, and starting from CWPRS, Garware ropes, then Neue Faser technique, that is in Germany, where I had the opportunity of visiting them, and Garware wall ropes, we have a lot of work with them jointly, and CWPRS is one of the pioneering institute in this field, and then Tenkate Geosynthetic, TechFab, and all the other established companies, they are all working on this. They are mostly manufacturers of geosynthetic products. So with this I conclude my lecture.